Good evening, viewers, and welcome to my channel. In today's lesson, some basic concepts in mathematics are explained. So we are going to look at exponential equations. This aspect of mathematics um, threatens students, and they find it very difficult to solve questions on exponential equations. That's why I've taken time to explain this one so that to help any student that is having any difficulty on exponential equations. So let's start. Let's start going. Exponential equations are equations which have a variable or unknown as an index or exponent. For example, when you have a to the power x is equal to a to the power y, this implies that x equal to y, provided that the bases a and the bases are the same. This is a and this is a, so just equate the powers. So x equal to y. When provided that a is not minus 1 or 0. So if this a is minus 1 or 0, this can't work. So any number apart from minus 1, 0. If here is 1, here is 1, here is 2, here is 2, you can just equate the powers, and that is all. Now, let's take some. Now, exponential equations may be reduced to linear equations, quadratic equations, and simultaneous equations. So this is an example of a linear equation. So after reducing the exponential equation, we can get a linear equation of this form. And we say this is linear because the highest power of x is 1. So this is linear. So this L means linear. Then we can also reduce exponential equations to quadratic. So this is the highest power of the variable is 2, so this is quadratic. And all these two can be considered as simultaneous equations. So all we can get all these from exponential equations. So let's keep going. So find the value of x in the following equations. I 2 raised to the power 3x minus 1 is equal to 4 raised to the power x plus 3. I 8 to the power x is equal to 0.25. And b, if 3 raised to the power 2x minus 4 multiplied by 3x plus 3 is equal to 0, find x. For this simultaneous one, to come in the next video, so I'll explain the solution of this one in the next video that will follow. So for this lesson, we are going to, or this video, we are going to concentrate on the AI, II, and the B. So the linear and the quadratic. So let's start solving the linear one by reducing these ones to a linear equation. Let's look at the solution to that. So if we have 2 raised to the power 3x minus 1 is equal to 4 raised to the power x plus 3. Now, in the first one, when we started with this, we said that when you have a to the x is equal to a to the y, this implies that x is equal to y. So this time around, if we have 2 raised to the power 3x minus 1 is equal to 4 raised to the power x plus 3, we can only equate this to that when the base of this is the same as this one. So here is 2, here is 4. So we can't equate them. We must make sure that the base of this one is the same as this. So then you have to change this 4 to 2 raised to the power something. But you know that 4 is the same as 2 raised to the power 2. So when you come here, you won't do anything to this. You have to maintain this one. Then you come here. Because this one that has to be changed to suit this base. So 2 raised to the power 2 multiplied by the expression x plus 3. So this 2 raised to the power 2 multiply this expression x plus 3. So when you come here, this 2 raised to the power 3x minus 1 is equal to 2 raised to the power 2 multiplied by the expression x plus 3. It is very necessary to put the expression in brackets, because when you put it in brackets, it will help you to know that the 2 is multiplying everything. If you omit the brackets, you may make a mistake, because the 2 will only multiply the x, but the 2 has to multiply the x and then the 3. So now that the bases are the same, we equate the power. So 3x minus 1 is equal to 2 multiplied by x plus 3. Now you do your computations here. So when you multiply this, you get 2x plus 6. And This 2 come here. So 3x minus 2x. So 6 plus 1. So s to be 7. Now, so that is how it is solved. So this one is linear. So reducing this exponential equation to linear equation, then solving them. Now this one is another linear one. 8 to the power x is equal to 0.25. 0.25 is same as 25 over 100. So when you punch this, reduce this one. 25 go here 1 to 100 4 times. So you have 2 raised to the power 3s is equal to 1 over 4. Now, you always want to make the bases to be the same. But here, we have 1 over 4. So 1 over 4 can be written as 4 to the power minus 1. Or you can also make it 1 over 2 raised to the power 2. So when you bring it up, it becomes 2 raised to the power minus 2. But let's take it from here. So 2 raised to the power 3 is equal to 1 over 4. So 2 to the power 3 is equal to 1 over 4. 1 over 4 is the same as 4 to the power minus 1. So 4 to the power minus 1, because this 4 is to the power 1. So when you bring it up, that's the inverse. So it becomes 4 to the power minus 1. So 4 to the power minus 1, the bases are still not the same. It is only this one that we have changed. We have brought it up, but we have done nothing to this base. So we have to change this base to suit this one. So 4 can be written as 2 raised to the power 2, but there's minus 1 there. So this bracket means that the 2 and the minus 1, they are multiplied. So if they are multiplying, it means that these 2 multiply negative 1. When I multiply 2 by negative 1, because of this bracket, get negative 2. So since the bases are the same, we equate the powers. So 3s equals minus 2, making s the subject, get minus 2 by 3. So when you reduce an exponential equation to linear equation, that is how to solve. You can solve more examples on that. And our last one, we are going to look at how to reduce an exponential equation to a quadratic equation by taking this example. So 3 raised to the power 2x minus 4 multiplied by 3 raised to the power x plus 3 equals 0. Now here, since this is 3 to the x, we have to change this one to a number 3 to the power x. But here 3 is raised to the power 2x. So we can write a 3 to the power x or in brackets squared, because when you do it this way, the same as 2 multiplied by x, you get 2x. So this one is the same as this. This is the same as this. So we know that 3 raised to the power s or raised to the power 2 is the same as 3 raised to the power 2s. But the idea is that I want to make it like this, look like this. But there was 2 attached, so the 2 come out. Minus 4 to the power, the same 3x plus 3 is equal to 0. Now you are saying that let y is equal to 3 to the power x. So it can be y, it can be m, it can be q, it can be any other variable apart from x. So y is equal to 3 to the power x. So wherever you see 3 to the power x, you put y there. So y here, y here. But here it is squared. So y will be squared minus 4y plus 3 equals 0. And this is a quadratic equation. And you know how it is solved. Multiply this by the constant. Find the factors of 3. That's when you multiply, you get 3. But when you add, you get negative 4. So after taking this through that, you get y minus 1, y minus 3 equals 0. When you consider only what this one, y minus 1 is equal to 0, then get y to be 1. Y minus 3 equals 0, then get y to be 3. So now we have gotten values for y. But we are saying that initially we said that let y equals 3 to the power x. So if y is equal to 3 to the power x, we have two values for y, 1 and 3. So you take the first one, which is 1. So 3 to the power x equal to 1. But I know that we can get 1 is the same as any number to the power 0. But here, since we are considering the base of 3, we say 3 to the power 0 is 1. Yes, so we are going to maintain this. So 3 to the power x is equal to 3 to the power 0. Now the base are the same. So equate the powers, then get s equal to 0. Also, when you come here, we have finished with the first one, y equals 1, and come to y equals 3. So 3 to the power s equal to 3. But 3 is the same as 3 to the power 1. Any number to the power 1 is the same number. So now the base are the same. So equate the powers. So x equal to 1. So hence we say that s is equal to 0 or 1. So that is how exponential equations can be reduced to either linear and quadratic equation for us to solve it with ease. In our next video, I will present the solution to of the simultaneous equation. Thanks for watching.